With this presentation, I'd like to introduce you to the solution family of products and approach to building tomorrow's systems. Solution family is the product of a collaboration between real-time development and OpenNetCF. Together, we have over 50 years of combined development experience. The solution family of products has been being developed for the last 12 years. It's originally created as an integration tool for real-time development, and we used that for over 10 years before releasing the product. Originally working on U.S. Army flexible explosive manufacturing, the product has demonstrated 24/7 operations in hundreds of applications over an entire decade. And we've been able to field industrial applications with bills of material under $400. Customers like U.S. Army, General Dynamics, Akuma, Mitsubishi have been able to enjoy the benefits of the technologies of Solution Family. So the incredible challenge is to support the integration of devices, computers, servers, and cloud services, combined to manipulate both data and rules to support any software-hardware integrated system. So a slight little challenge we gave ourselves. And our solution was to provide a robust engine and development tools, two things, architected to enable the user to create and target both data and rules throughout a system of intelligent devices through cloud services. So you could be with intelligent devices, computers, or cloud services. And this system has the flexibility and extensibility required to address any solution. So let's take a look at developing a solution with this technology. Remember, we have an engine and we have a set of tools. So let's take some devices, let's take some management computers, and let's take the cloud. Put that together. We have a laptop we want to build a system with, and we're going to network all of those together. So the first thing we'll do is we'll take the engine from Solution Family and deploy it to these various devices throughout our system. And then we'll take a tool called Solution Builder, and we will then connect to all of those engines in the field. Now let's start building the system. And the interesting thing here is you see a set of devices, a set of computers, and a cloud. And really from the Solution Family approach, we look at that as just the platform to put the appropriate logic and the appropriate data collection so that we can build the application that we're looking at. So the first thing we'll do with that device is go ahead and configure the I/O so that we'll start receiving information, and that'll be deployed to a particular device. Again, you can connect to an entire network of devices, and then you'll place the appropriate configuration at that location. The next thing we might look at is a configuration for a service that's monitoring temperature, and that temperature information then would be deployed to an appropriate location that's receiving temperatures, and that would be in the form of a model, the yellow box. We might have a statistics service. A statistics service allows us to create and aggregate information from devices, from any information we have there, and produce brand new information on any of these engines. And we'll take and deploy the statistics to a particular computer running at the management level. And then we'll use the same mechanism and deploy statistics to other locations in the cloud or at other management levels. We'll take data collectors, where we just drag in items or pieces of data from the device, drag it into a location, and then we'll take that and deploy it to a device. Or we might also take that and deploy it to another device or up into the cloud. So again, we took our data collection, and then we come in with controls or rules that the engines will follow. So we'll give it, if something is happening and this value is on, then go ahead and call this routine or store that data. And we'll take that control and describe it in a series of steps and take that control and deploy it to a particular device. A unique feature of taking these rules and the ease in which we can manipulate them is we can actually take rules from one device and deploy it and copy it to another device. And that really gives us a lot of power, so we can have several vehicles that are in a telematics system all following the same rules. We can push those rules on the fly to solution engines. So again, we have taken those controls and deployed them there, or we can have other forms of controls and move it to the cloud. So again, that's what the solution starts looking like. And again, from the solution family approach, now we go online with this, we have all of these interactive, the data moving around, the statistics being calculated, and as we look at it from the solution family, that's what we see when we see this whole network of devices out there that we work for. So again, we're taking intelligent devices, integrating hardware, applying models, control, aggregating new data, all to perform a new solution. So the keys to the solution family are creating intelligent devices empowered with capabilities to create, move, and manipulate both data and rules. Not forgetting the rules, because a lot of times when we do data collection, the rules actually tell us what data to collect and when. Remove the limits to what you can address with an extensible architecture for both the engine and tools. And the key to this technology is the architecture that allows us to extend it. We moved into many vertical markets by simply extending and adding new modules into the architecture, and it's built for that, and not only the engine but the tools. So as you want to grow this into another market, you can easily move it there and extend it. Both the tools and the engine are extensible. In a single user-targeted tool, we move and define data and rules from the floor to the cloud while storing anywhere in between. So again, it's powerful so that we can move all of this information anywhere we'd like. We leverage and create information from your oldest legacy machines, machines that have no intelligence. We strap some sensors on, get information to tomorrow's newest devices, and those devices may have new protocols. And we're not worried about new protocols. It doesn't break the system. The system is designed to extend and add on new protocols whenever you would need to. And we're moving from the confines of creating embedded applications and the mentality of thinking about creating embedded applications to the freedom of creating solutions. And when you look from devices to the cloud and you think about just applying the appropriate rules and data at any location, you start questioning, what does the word embedded mean? When an embedded device has the same power to run rules that the cloud does, then really what does embedded mean? And in defining an intelligent device, we throw the word around a lot. It's, again, we take away from this that an intelligent device can manipulate data. It can create it, aggregate it, collect it, either locally or to the cloud. It supports rules, the ability to define and assume rules so that you can push down new rules to a device and completely change its behavior. Always supporting occasionally connected scenarios, and those are the toughest to do, but the engine's built for that from the beginning. It's extensible with new I/O systems and models, so as you move to a new environment, a new vertical that you want to support, it's easily supported. It stores easily to the local or cloud storage mechanisms, and those are designed as plugins to the system so that we can easily support a cloud like Azure or move over to MQTT and support a cloud running with an M2M interface. And can be any computer from the floor to the cloud. Again, an intelligent device is any computer from the floor to the cloud. It's just not what we traditionally refer to as devices, but we can put that intelligence anywhere in the entire system. So we started the solution family with looking at process control and machine tool control. Process control being traditional PLCs running in a plant, running recipes and helping with explosive manufacturing, to machine tool control where we would improve the behavior of a machine tool or be able to monitor it and change its ability to produce and cut parts much more accurately. Moved into security, allowing a security system to have multiple behaviors, and that allows you to be able to approach securing an area and define what those individual things might be, the individual behaviors that you might want to have. Building automation is an area where we've excelled in looking at applying these technologies and extending it with wireless technologies like Zigbee, and having all of that information pushed to the cloud so that it can be easily visible from any of the building managers, so they can see that information, or the maintenance personnel. And finally, we moved into telematics, which is taking these intelligent some devices, placing them on the bus, putting solution engines on them, and enabling that bus to get proper maintenance information, get routing information, and control the interior mechanisms within the bus, all on the same solution engine, all integrated into a large solution that might be the entire telematics process for a municipality. And to wrap up, again, we look at the solution family as two things, the extensible engine and the set of development tools that are targeted at the user. They enable the creation of intelligent devices that can collect, create, and aggregate any data and cloud publish that information, as well as define and assume new behaviors with all of the features for Solution Family applicable to all markets. Again, everything that we looked at here for the Solution Family really has been market independent. So I thank you for your time. Hope you got a good overview of exactly what's going on with the Solution Family, and I invite you to take a look at the following presentations to get more detail. Thank you very much.